So we're going to start with how to use the calculator to do fractions. Can everyone see the calculator on your screen? It should be showing in like a little pop-up video. Yes? Okay, perfect. So your calculator will be red. It's the exact same as this one, but it's the red color instead of blue. And when you turn it on, you can clear it out if you already have some stuff there. And you can use it to solve any fraction problem. So the fraction problem is 1/3 minus 5/7. If you can do it by hand, great. But if you forgot how, then on the calculator, you would start with 1. You start with the first number on the fraction. And then this ABC button is the fraction button. If you hit ABC, it puts a little corner. That's basically saying the next thing is going to make this a fraction. So there's your 1/3 minus 5, and then again the ABC button, 7. And when it pops out the answer, it just gives you the simplified final answer. You don't have to do anything to this. It's just -8/21. So there's not a whole lot of fraction problems, but if there are fraction problems, this button can really help out.
Or being able to make your own schedule.
It can also reduce a fraction for you. So this fraction is 50/125. You can reduce it by hand, again, if you know how. But if you forgot, you can just use that ABC button, 50 ABC 125. And all you do is hit equals. Before we had to, do the subtraction sign and put a second fraction. This one, it will automatically reduce it for you once you hit the equals button. So we did just have someone join. We're practicing how to use the calculator really quick. I'm showing you a lot about this ABC button, which will help you solve fraction problems. It can even help you with mixed fractions. Now we have 2 1/4 multiplied by, that's a pretty small dot, but that's multiply. Multiplied by -4 3/8. So when you type this one in, we're still going to use the ABC button, but we do have to do a little bit more. We're still going to do 2. We'll do the very first number, which is now the whole number in front. Then ABC, 1, ABC again, 4. So this is now the mixed number, 2 1/4. Multiplied by negative, so we do need to use the negative symbol, not the minus. -4, ABC 3, ABC 8. And then you hit equals. So this time when it shows the answer, the little U is just separating the mixed number from the fraction part. So again, this can just make it a lot easier. You just type it in. The final answer is -9 27/32. So on some problems, it's not helpful to use this ABC button. We don't want to overuse it, but if there's a problem that wants a fraction as your answer, we definitely want to use that ABC button. If you have a problem where something like this, we want to put it in order, we want to compare the decimals. So to get 31/4 as a decimal, instead of a fraction, we can't use that ABC button because it's just going to give us a fraction for it. So the 31/4, does anyone remember what math symbol we use in order to make this into a decimal? Are we going to add, multiply, subtract, or divide?
What is missing? Oh, yeah, you said. At the top, when you try to click save, it's like you can't. The steering isn't right. But you save it and it doesn't pop it up.
If you have an answer, you can type it in the chat box, or you can unmute yourself and say it to all of us. Good. The fraction bar means to divide. anytime you want this as a decimal, we want to actually do the division. So 31 divided by 4 gives us 7.75. This time we did not want the fraction. Mixed numbers were a little bit different. The 5/8 part is still divide, but the mixed number part, we have to do some addition. If you do 7 plus 5 divided by 8, that will give you the decimal for this fraction. So 7.625. And then the final one, square root of, well, not the final one, but the final one we need a decimal for, square root of 50, we also need to know how to get to the square root button on this calculator. So it's kind of hard to see, but if you look at this x squared button, right above it, there's a tiny blue square root symbol. So to get to those tiny blue symbols kind of in between the buttons, you have to hit second, and it's hard to see, but it'll actually show here that it's on the second features. It'll pop up that you're using the second features. And then we hit x squared to pop up the square root. And I accidentally hit one too many buttons, so I'm going to hit delete to go back a space. And then 50, you can close your parenthesis, hit equals, and now we have a decimal for square root of 50. I believe most testing centers will provide you with a calculator. If you want to do any practice with them beforehand, they're only about like $20. You can find them at Walgreens, Walmart. Those are some of the main places you can get this specific calculator. This is literally the only calculator they will let you use, is this TI-30X. So let's go ahead and finish this problem. We got all the decimals, so now we need to put it in order from least to greatest. So what is our smallest number for this problem?
So we got him involved on
Okay, 7.625. We have two people saying 7.625. So there's one small detail. That's the second smallest number, because when there's this 0, yes, there's a 7 next to it, so it looks like it might be bigger, but the 0 makes this actually a smaller number. Good. So now we know 7.01 is the small, or sorry, 7.071 is the smallest. You can't forget those zeros. And they do problems like this just to try to trick you a little bit. They make it so there might be some confusion. So that's square root of 50 first. So we've found the smallest. Now what's the next smallest? We kind of already said, because we had to talk about the difference between these two. So 7 and 5/8 is next smallest. And what comes next? The 31 over 4, 7.75. And then we only have one more left, 7.82. So if you're ever confused, where they all start with the same number, they all start with 7s. If you make each decimal the same length, so we have the 625, that's 3 digits, and the 071, that's 3 digits. The other two you can put zeros on to make them 3 digits. And the advantage of doing that is now you can just think of these decimals as regular numbers. If we have 750, 625, 71, because it's 071, and 820, we know which one's smallest out of that list. So if you can kind of take it out of decimal format, that's one strategy to get them in the correct order. So I'm going to take the calculator off for now. So we practiced doing our fractions with the calculator and doing our square roots. One quick recap for the people who joined in. To make a fraction in your calculator, there's this ABC button. So 5 and this little corner mark 6 means the fraction 5/6. And you can do mixed numbers too by using the ABC button 2 times. 4 corner 8 corner 9 is 4 and 8/9. And then you can hit enter and it'll do whatever math operation you want. Or we learned how to use the square root button by doing second x squared. The second button accesses any of these small blue writing in between the buttons. And it's always the blue above the button you're actually pushing. And you can type in a number to take the square root of it. So a little recap. I'm going to take the calculator off for now because we don't need it for a little bit. So you see a big long list here. When you're working with word problems, I wanted to focus a lot on these free response problems you'll see because they can be worth quite a few points. So when you're working with word problems, you kind of need to know how to translate the math into the math symbol it's asking you to use. So we have a whole list. I'm actually going to make a picture of this and send it out so that you have it. So you don't need to write the whole thing down because that'll take a while. But each of these is kind of a list of words that mean an actual math symbol. So like increased by, more than, combined. This whole list all means to use a plus sign. You're adding stuff together. Subtraction, decreased by, minus, less. Difference is a big one. You'll see difference a lot. So that's one that you really want to make sure you know. That's use a subtraction symbol. And sometimes they do like real life situations. So they might use a word like withdraw, where you're taking money away. That still means subtraction. So I can't, put every word you might see on this list. Sometimes you just have to know from context. You have to know if I have a bank account, when I make a deposit, it adds money in. So deposit was in the add list. And when I make a withdrawal, it takes money out. So that's subtraction. Multiplication and division can also sometimes be confusing because they have a few words that actually work for both. Per can mean multiplication, but per can also mean division. Most of the time it means multiplication. Every once in a while it means division. So you kind of have to look at the context of the problem to determine that. So we're going to see a couple where we have some multiplication going on. Also with multiplication, you might see words like twice or triple, where it means multiply by a specific number. So when we say multiply twice, what specific number are we going to multiply by?
Send it to my, you can send it to my email. You can just take a picture of them if that's easy enough, and send it to me. And I did send you an email when we spoke last.
2. Multiply by 2. And triple specifically means multiply by 3. Most often you'll see those. You could see quadruple, which is multiply by 4. I doubt they'd ever do quintuple, but technically that's multiply by 5. Most of the time it would be twice or triple. Same thing with division. They can use a specific dividing. Half means divide by 2. And then equals actually has a lot of words as well. Equals can be is, are, was, were, gives, yields. So there are words specifically because sometimes they'll want you to set up a whole equation where you actually use an equal sign. There's also word problems where they want you to use an inequality sign. so we need to know what these all mean. Less than is the less than symbol, so the pointy part is to the left and the open part is to the right, but no line underneath, because less than or equal to is when you have that line underneath. And no more than is tricky. Because it has the word more, we really want it to be greater than, but it actually means less than or equal to. If you want to spend no more than $100, you want to spend less than or exactly 100. So then more than or greater than, that's the greater than symbol. More than or equal to, or greater than or equal to, that has the line underneath. And at least is the same version as no more than. We see the word least, so we want it to be less than. It actually means greater than or equal to. If you want to make at least $100, you want to make 100 or more. And then two just random ones they use sometimes in questions. Squared means raise something to the second power. And square root means the actual square root symbol. Those are very specific. They can't say the word squared and mean for you to use the square root symbol. So you've got to watch out for that because they are specific words that mean specific things. So let's actually apply some of this. Again, I'm going to take a screenshot of that page and send it out so you can have those words to study. So these are all taken from those past OGT tests. So these are actual ones that have been asked before. Cameron had $500 in savings on January 1st. Quinn had $800 in savings on January 1st. Cameron deposits $20 per week into a savings account. Quinn withdraws for $15 per week from his saving account. So let's stop with that paragraph. What are some of those keywords that we have to actually translate into math symbols here? So what's one or two keywords from this paragraph that actually means do addition or do multiplication? Per, that's an important keyword. Any other keywords you see?
It's 313.
Had.
576.
Good.
0090.
There's two more I'm thinking of.
Tomorrow they open at 8:30. Yeah.
Withdraws is a keyword. And deposits is a keyword. Good. Good. So those are some of those keywords that now we have to translate into actual math symbols. So if Cameron had $500, we're going to start with Cameron. So Cameron equals 500. Had meant equals. That's how much he started with. So then they switch over to Quinn, but we want to just focus on all the Cameron parts right now. Then it says he deposits $20 per week into his savings account. So when it says deposits, what did we learn that meant as a math symbol?
This guy wants to get his
Add. That means plus. Very good. Thank you. So 500 plus. We're adding the 20 per week. So $20. Now per, like I said, most of the time it means multiply, but it can mean divide. In this case, it's going to be multiply by the number of weeks. We don't know the number of weeks. So this is where a variable comes in. So I'm going to actually add this to our chart. We use a variable when there's something we don't know, but it's still part of the equation. So a term we have no number for, but it's still part of the equation. Sorry, that was a really bad F. So weeks needs a variable. Often we use the letter, I used C for Cameron, so often we use W for week, but this is where we should read the second paragraph. In your answer document, write two equations, one for the amount of money in Cameron's savings, X weeks. So when they put the letter X next to this information, this term that we don't have a number for, that's the variable they want us to use. So if you put W, they're probably not going to give you full points because it specifically said in the question to use the letter X. So if you have something over time, like wages, you make $15 per hour, $20 per week. Using time usually means multiply instead of divide. So I'm going to add that to per over here. Usually involved with time if it wants multiply. So there's Cameron's equation. He started with 500. Cameron had, there's our equal sign, 500. Then he's adding, because he's depositing, $20 per week. So now I want you guys to write the equation for Quinn. Quinn's information was he had $800 in savings, then he withdraws $15 per week. So what equation would we have for Quinn? We are going to use a minus sign. Then we had someone say 800 minus 15. That's close, but not complete. Everything here is right. 800 minus 15 is correct. It's just not the final answer. So now we have one more person. We need those variables to get the actual full equation. Quinn had, so that we put the equal sign, Q for Quinn equals 800 minus 15 times X. And you don't have to write the multiply sign in. They're not going to dock you points for having it there, though. So make sure you include those variables. Otherwise, you don't get those full points. So now we've done the first part. Write two equations. We have answered that. There was still one more paragraph. Determine the number of weeks until Cameron will have more money in his savings account than Quinn. Show your work or provide an explanation for your answer. So if it's more money, I'm going to go back to our list. What did more tell us to use? True. More does sometimes mean add. This is where some of these translations can get confusing. We have to kind of look at the context. So the problem with adding is it didn't actually want the total amount between Cameron and Quinn. It just wanted to physically know when will Cameron, his total amount of money, be more than Quinn's total amount of money. So there was a second more than down here where we use the greater than symbol. So this is where the translation can just be tricky. Sometimes we have to think about the context and think, did they want Cameron's plus Quinn's amount, or did they just want to know, does Cameron have more money than Quinn? So a comparison, we're just comparing Cameron to Quinn, that's going to be the greater than or whatever inequality symbol. The actual total amount, if they said, how much will Cameron and Quinn have together, then that's when they want an actual addition or subtraction. So now that we've cleared that up, hopefully that will be clearer in the future. It's something we didn't address before. So there's a couple ways to do this. You can actually use the full equations. You can use Cameron's equation and say, I want to know when Cameron's equation is bigger than Quinn's equation. We're going to practice how to solve this because equation practice is always good. Probably this is not the way you're going to actually do it on the problem. It's really hard to think in terms of equations, so it's not going to be the first thing your brain thinks of. But let's practice solving it, and then I'm going to show you the second option. So when you solve an equation, you notice we have an x on the left and an x on the right. That's an issue. You can't have variables on both sides. We need to get them to the same side. And we do that using our opposites. Even though it's an inequality sign instead of a full-on equals, we still solve doing opposite operations. So this minus 15x, what's our opposite of subtracting 15x? So opposite of subtraction, basically. Good. Adding. Anytime you have subtracting something, to move the whole term, removing the 15 and the x, we add it, which gets rid of it. A lot of the times you'll see it written underneath, and you'll see them cancel both out together. Or if you just like writing it on the other side and canceling one, that works as well. So now we have 500 plus 35x. When we combine these together, we do 20 plus 15, which is 35.
Oh, okay. Do you know what that is?
So now we need another opposite. We got all our x's to the left side. Now we want to get this 500 over to the 800. And there's no sign written in front of it, but anytime there's nothing written in front, you assume it's positive. It can't be negative or minus unless they write a negative or minus sign. So if this is adding 500, what's our opposite of adding 500? Subtract. Good. So again, that just cancels that out. We use the minus 500 to take it over to the 800. I'm running out of room down here, so I'm going to have to write up here. We have our 35x still, greater than, then we do the subtraction. 800 minus 500 is 300. So now we have 35 next to x, greater than the 300. We still want to do an opposite, but we only want the opposite with the 35. Before, when we had variables on both sides, we had to add 15x over. Here, we just want to do the opposite to get rid of the 35 only and leave the x. So this one's kind of the last tricky one. Does anyone remember how to do the opposite with our 35 next to the x? I don't see any answers so far. So the thing we have to remember is that that is actually 35 multiplied by x. Anytime there's a number next to a letter, it's actually multiplication. So our opposite that we almost always do at the end of every equation is to divide. And it's the toughest one to remember because they don't actually show that it's multiplying. They are not going to write 35 times x. You have to know, oh, that's actually multiplication, which means my opposite is division. So this 300 divided by 35, I don't know without a calculator. I'm going to bring the calculator back up really quick. 300 divided by 35 is 8.5. You'll notice the decimal takes up the whole thing. There's a decimal after the 8 that you probably can't see because it's small. Your calculator just can't continue. Really, there's probably more, but your calculator can only show so many things. So we only take the beginning part. 8.57 should be enough. So the other thing though is that this is a real life application. It said determine the number of weeks. So the number of weeks needs to be an integer. They don't want 8.57 weeks. We don't usually talk about weeks that way. They want an actual number of weeks. So for this to happen in this real life situation, we actually have to always round up. This one in real life would round up. The 5 next to the 8 takes it up to a 9. But because it's an application problem, even if this said 8.1, we would round up to 9. 8 weeks wasn't quite enough. He needed a little more than 8. But since they're only calculating this every week, we have to go up to 9 to be for sure more money in Cameron's account than Quinn's. So one way to do it is to do this equation stuff. But again, like I said, this is probably not the way you're going to do it. Probably the way you're going to do it is just create a table. If we have Cameron and Quinn, and we have their starting amount of 500 and 800, then after week 1, we're going to add $20 to the 500 because it said he was depositing $20 per week. So 500 plus 20 is 520. And then Quinn was minusing 15. So subtract 15 is 785. And you're just going to write out the whole chart. And you should write out the entire thing so they can see you know what's going on. 770. So you just keep going with each week until Cameron's money is more than Quinn's. So again, we're adding 20 here each time and minusing 15 over here. Any questions about writing it out or any concerns you have with these free response questions on the OGT? I don't see any questions. I'm going to finish the table really quick just to show you where the final place to stop would be. So here at week 8, we have 660 compared to 695. Oh, did I miss one? 785, 770, 755, 740. Oh, 695 should be week 7. My chart got a little bit smushed. Then we're down to 680. So now you see Cameron's pretty close to Quinn, but still below. When you hit week 9, that's where the shift happens. Now he suddenly has more money than Quinn. So you're looking for that change. Okay, so here's another. Sorry, that was supposed to say Frank. The name is Frank. He makes and, sorry, lots of typos. Makes and sells small picture frames. His revenue from sales can be represented as R equals 13.60x for X frames sold. The cost of making the frames can be represented as C equals 5.80x plus 120 for X frames made. In your answer document, determine the minimum number of frames Frank must make and sell in order to be greater than his costs. Show your work or provide an explanation for your answer. So I liked including this one specifically for the words revenue and cost. They use these words kind of assuming you know what they mean. Let's talk about what they mean. So when you own a business, the revenue is how much money you make overall. So without considering anything else, whatever you're selling, how much you make off of that. The cost is how much you spend making something. So an example is maybe you know how to knit and you want to make a blanket and sell it. Well, it costs you money to buy the yarn. So maybe you spend $50 on yarn and then you sell the blanket for $200. Revenue is that $200. They might also sometimes use a word called profit. Profit is how much money you actually make overall. If you do your revenue minus your cost, that is your profit. Cost. So again, let's take that yarn example. If you spent $50 buying the yarn and you made $200 selling the blanket, your profit is actually $150. You had to kind of pay yourself back for the cost of the yarn. So that's what these words mean.
Oh, okay.
So now we're going to do a similar process to what we actually did with those bank accounts, except they didn't have you make the equation for yourself. They just told you revenue is the 13.60x and cost is the 5.80x plus 120. Determine how many frames, the minimum number, the smallest possible that Frank must make, so his revenue is bigger than cost. I want the revenue number to be bigger than cost. So for this one, since they didn't tell us, on the last one they told us add 20 every time, or minus 15. We kind of have to guess and check. You could actually do the equations like we did on the last problem, or you can just make your list right off the bat. So we kind of have to make a guess and see where we're at. So if we guess like 10 frames, so we're kind of making a little table here again to compare. So if you guess 10 frames, to figure out the revenue, we're going to actually plug that number in that we guessed. Instead of the letter X, we're plugging in an actual value. We've guessed 10 frames. 13.60 times 10 is $136. So then we check cost with those same 10 frames. So for 10 frames, and I'm going to bring out the calculator again. This one we should plug in. 5.80 times 10 plus 120 is 178. So we check and see, is the revenue bigger than the cost? Did we get a revenue bigger than cost for that guess? We did not. Revenue is still smaller than cost. They're kind of close-ish. So we're going to make another guess. What should we try next? We tried 10 frames. How many frames should we try next? Okay, 13. Some of you might have thought 13. Some might have jumped up all the way to 20. It doesn't matter. Guess and check. You kind of just have to take it as it comes and take your information to keep guessing again. So this time we're going to try 13 So how much do we get for revenue when we use 13? $176.80. Just double check. That sounds right. But I need to type it in. Yep. So 176.80. Good job, guys. So now what do we get if we use 13 for cost? $195.40. Let's double check again. 13 plus 120. 195.40 is correct. So we brought it a little bit closer, but we're still not quite there. Cost or revenue is still smaller than cost, and we wanted bigger. So what do you want to try next? What number of frames would you want to try next? 15. So now we try our 15. And on the exam, I actually recommend writing out this table. You don't need to necessarily, and don't make a mistake and write the wrong number here. I wrote 13 instead of 15. You don't necessarily have to write this part, 13.6 times 15, but you definitely need to write the answer you get once you plug it into a calculator. So 13.60 times 15 is 204, someone says, and you are correct. Thank you. So then we do the same thing. Try 15 for 5.80 times 15 plus 120. And that gives us 207. We are super duper close. 204 is just a tiny bit less than 207. So when you're doing something where you have to actually prove, we want to show both. We want this 15. Now we're going to go up just one more to 16. So what do we get for revenue with 16? And what do we get for cost with 16? $217.6. Very good. That is the revenue. And since it's money, I'm going to write 60 just so we know that's the 60 cents. And then, so 207 is when you do 15. That's the number we got for 15 frames. So make sure you bump it up one more. Now we're going to try 16. What do we get for 16? So we get 212.80. Good. So you should now provide an explanation. We did show work doing this table, but it's always good to also include an explanation. And so you might write something like, the minimum number of frames, kind of take from the sentence. It said to determine the minimum number of frames. The minimum number of frames Frank needs to make is 16. The table itself showing that 15 went from less than, 15 went from less than to 16 going to greater than. Showing that table is kind of showing the work, but make sure you address and say, this is my final answer. I know this means the minimum number is 16. I also wanted to include a geometry one. So in the booklet, it just includes a grid. It's not going to include the graph itself. You're going to have to draw a graph in for some of these geometry free-response problems. So the vertices of a kite are located at points P, -2, -1, Q, -1, -2, R, -2, -5, and S, -3, -2. The image of the kite is reflected over the x-axis. Here's some keywords. They weren't on our lists because we didn't include any of the geometry keywords, but those are some important pieces of information. And then the reflected image is translated 3 units to the right and 2 units up. In your answer document, provide the coordinates of the vertices of the final image of the kite. We want to know the end image. Provide a graph, calculations, or reasonings to explain how you determined the coordinates. So when you draw out your graph, you normally draw in an y-axis. Hopefully you can draw it a little bit straighter than me. Sorry, this is really hard to do with a mouse. I'm going to cheat a little bit because they're kind of coming out really bad. So I'm going to use a fake line. Pretend I drew this by hand. You need an x-axis. You don't have to include the arrows on the end. They're not going to dock you points, but most commonly we do. And you should label them as x and y. So once you draw those in, then you have to actually plot these points. So every coordinate in the coordinate plane has your x or your y first. And the x tells you go left or right. The y tells you go up or down. So point P, I'm going to get a bigger arrow just to have it highlighted a little more. Point P, we start at the center, and it says -2, so negative tells you to go left 2 spaces. Count 1, 2 spaces. And then -1 tells you to go down 1 space. And they should already have the grid lines. You don't need to draw in all the little tiny boxes. So that is point P. And you would want to label it with a P. Point Q, -1, -2, that goes left 1, down 2. Point R is -2, -5. We go left 2, down 1, 2, 3, 4, 5. And point S is -3, so left 3, down 2. So each point, I always went back to the center or the origin. This can be called the origin before drawing it. So now that we have our shape, we need to follow the instructions. The first instructions said to reflect over the x-axis. So when we say reflection, does anyone know what they mean when you want to reflect a figure? What's a more common word for a reflection? Mirrored, that's a common word, mirrored. Or we often use the word flip. Reflection, mirrored, flip, those all mean the same thing. So we want to actually flip it across the x-axis. When you mirror something, like when you look at yourself in the mirror, it actually flips your face. The directions aren't changed. We're going to actually flip this shape and it gets flipped upside down. It's going to look something like this. But we need to know exactly where it's going to be. So we have to do some counting to figure that out. To mirror it exactly, you take a point, so like point P, and you see how far it is from the line you're actually flipping over. They said to flip over the x-axis, so we say, well, we're one space away from that line of reflection is what we call it. To do the flip, we just go that same distance above it. We're going to go one space above, and that takes us to the new point P. So the new point P, which they call the image, that's this fancy word here, they'll put a little apostrophe. I don't think you'll be docked any points if you don't put an apostrophe, but if you see something like this, which you can't really see because I'm trying to fit it in here, but P apostrophe is set P prime, and it just means that's the new point.
Oh,
so now we have to flip the other ones. If we look at point Q, how many spaces is Q away from the x-axis? 1 too many. It's actually only 2. And the common thing that happens here is a lot of people say 1, 2, 3. The first space you haven't moved. The first space is actually considered 0, or the first dot. So you go 1 space after you make a movement, a second space after you make a movement. So don't start the counting until you've actually moved from the original point. So 2 spaces up, and then we go 2 more. So again, this first spot we don't count as a movement. We count moving 1, moving 2 takes us here to Q prime.
Some people sometimes have to drive hours to go take their
So then we want to move S. How many spaces is S away from the x-axis? 2. And then we go 2 above is S prime. And then R is going to be a little hard to tell because we have a lot going on here. How many spaces is R from the x-axis? Good. 5 is correct. So then we go 5 spaces up from the x-axis, from that line of reflection. 1, 2, 3, 4, 5. And we put R up here. And again, even if you don't remember the apostrophes, just labeling them P, Q, R, S should be enough. Here's our new kite. Also keep in mind, if they said reflect across the y-axis instead, the y-axis you'd end up over on this side, just to show you how it can change. You have to know what you're flipping over. So that is our flip. You'd probably get half points if you stopped here. You have a picture for the flip. The translation, it says the word translate, that's a fancy word for a slide. And basically all you do is count however many units they say. So they said specifically 3 units to the right and 2 units up. We're going to take each point and do that counting. Again, the point you start with is 0. You haven't made a movement. But point P, we count 1, 2, 3 spaces to the right. That's what they told us to do. And 1, 2, up. So you have to do that in a continuous movement. Do 3 up to the right, then 2 up, all at the same time. So when you have 2, they'll do P double prime, 2 apostrophes. And now we just do that counting with each point. For Q, we count 1, 2, 3 to the right, then 1, 2 up. And for S, we count 1, 2, 3 to the right, and 1, 2 up. A second option, if you don't want to count for each of them, if you figure out how far Q away is from P, it's going to be the same away from P. So then R, we go right 3, up 5. Sorry, I said the wrong word. Right 3, up 2. And I went 1 too far. So R should be here. And that's your final answer. They should give you full points for that because one of the instructions just said provide a graph or the final coordinates. But you could actually list the coordinates by counting from the origin. So to write any coordinate, you always go from the origin. So like point P double prime, you went right 1, up 3. So that's 1, 3. Or Q double prime, you went right 2, up 4. So that's 2, 4. Providing the graph should be enough though. You don't necessarily need to write out the actual coordinates. And R would be 1, 4, 5, 6, 7, 1, 7. So I think we're going to stop there for today. It's a little bit early, but these word problems take so long, we can't make it through another one. We're not going to have very many more live sessions because most of you are taking the OGT next week or the week after. And then we'll take a break from live sessions and start up closer to October if you have the option of trying in October. Every set of students is different, so some of you must take it now. Some of you might have some extra time, but Amy's the one who can tell you that. Thanks for coming. I'm really glad you guys came and participated, and I will talk to you guys on Friday. The next one was Friday at 11 a.m., I believe.